a very good graphic designer, because I usually work with good graphic designers that add the CSS. So everything that's styling is supported with Glimmer, but it's also just CSS. So thank you. So however, I do have one sample that is designed nicely, which is to do MVC, because I simply took the CSS of the original sample. But this is to do MVC built in Ruby. So you can see I have a to do MVC Glimmer component. The markup of it is this. It's a div that has a section that has a new to do form, which is a custom component, a to do list, to do filters, to do MVC footer, and that's it. The nice thing is everything is written in Ruby. I don't have to switch between HTML and JavaScript, or HTML and ERB, or HTML and something else. I can just stay in the same language, which makes me more productive as a result of that. So now if I run it, I get the to do MVC app that I mentioned to you. So I can say, let's just say I have to do shopping, fixing, cleaning, etc. And I can like do this and then filter things out. It's very fast, as you can see. Even though it's written in Ruby, it's like super fast, because in the end, it is JavaScript that's running, not Ruby. So that's it. So I just wanted to show you a quick sample. And then next, I'm going to actually walk you through a number of other samples in this app. So this app is actually an online hosted Rails application. The project of it is in this repo, sample-glimmer-dsl-web-rails7-app. And I hosted it online, so I'm showing you here the online hosted version. So I already walked you through Hello World, so let's do something more sophisticated. Hello button. So the simplest way to get started is not to build a component at first. I'm showing you the building blocks that will lead us towards components. First, I can just write any syntax and it would get rendered on the screen using a Ruby DSL. So here I'm just writing a DSL express or whatever paragraph of code that's saying, okay, I have a div and it's got a button inside it, and then it's got an on-click listener, and then if I click it, it'll show an alert. Think of this double $ as the window in JavaScript, and basically this is me writing JavaScript in Ruby, except it's a declarative DSL. So I'm declaring elements. I'm declaring a div. I'm declaring a button inside it. And then anything that's supported in HTML for listeners, like on-click, for example, is supported here. So if it's a select box, for example, it would be on change instead of on click. But yeah, you get full support for HTML here. So if I run it, it's just a button. And then if I press that button, it's going to say hello button. That's it. It's a very, very simple sample. So again, I'm just walking you through samples while graduating the code in difficulty. So button counter is a more sophisticated button. This is a button where, let me run it first for this one. It's a button where every time I click it, I want it to increment the number. That's all it does. And the text inside the button is what changes. So this one is, if I look at it, this one has a model. So I built a Ruby model. So all the Ruby object-oriented programming capabilities are available here. So I can just follow MVC. I have a model. It's called counter. It keeps track of a count, which starts as 0. And then here, I have a button counter view component. And before render, I initialize the model as a variable. And then I can just use the model with data binding. So here, thanks to Ruby's metaprogramming capabilities and operator overloading, I can use this arrow to basically data bind the data of the count on counter to always update the inner text of the button on every change. That's what this is saying, essentially. Here, I added an option that does conversion. So this is a converter. It's a lambda, or a function, that will take the value and convert it to something else right before it stores it in inner text. So here, I'm taking the value and just embedding it in a string using string interpolation. And here, finally, here, there's a listener on click. And all I'm doing here is I'm incrementing the count in the model. But since the model is automatically observed with this unidirectional data binding that we have here, as soon as I update the count here, it's going to go here and format it into a string and then put it in the inner text of a button. So that's exactly what we saw here. Okay, so let's go with something else. Hello form. So this is a form that will let me enter a name. So I can, if I type enter, it has validation. So it's saying, you have to fill out the field. Let's just say I put John Smith and enter. If I hit enter again, it won't like it. If I do this, it won't like it. I have to put like a real email. Now, as soon as I hit enter, it actually added it here. So we have a table and a form, and they're linked together. So the way this works, again, is we would just use the HTML DSL. So we build a div that has the title of the form, and then just a basic form, and it's got a bunch of fields. Now, here's something that's very unique to the Glimmer Ruby DSL. It cannot be done in real HTML or JavaScript or other things. I can assign elements into variables, and I can just treat them as objects. So I can just do basic object-oriented programming on any HTML elements. So if we assign this input to a name input, and this one is an email input, then here, for the submit button, we basically, on click of the submit button, I can grab those two inputs and say I want all of them to be valid. So I'm invoking the check validity method in Ruby, sorry. Actually in JavaScript, yes, but from Ruby syntax. And Opal will automatically allow me to use Ruby conventions. So I'm just saying check underscore validity. I don't have to say check capital V validity. So after I check them, here I just do what I do in JavaScript normally. I would prevent default, and then I would take the table. I would reopen its content, just like how in Ruby we have open classes. In Glimmer, we have open elements. So any element could be reopened, and then I can shove into it a TR, meaning a table row with two data items, the name, the value of the name input, and the value of the email input. Finally, I clear the name and email fields, and I restore the focus to the name. So this is like low-level code of me doing view stuff in Glimmer without using components. Now, once we upgrade this code to components, then I can upgrade the code to the MVC pattern by putting most of the logic in the model. But I'll show you another example of that later. Here's the table. Table is just a basic HTML table, nothing special. Here I have some styles. So you can embed CSS styles directly here if you want. And here I'm just using pure CSS. Or you could externalize the CSS and put it in a separate file. That's also supported. Or you could do a hybrid approach of both. Or you could even use a Ruby CSS DSL, which I'm going to show you in a second. So let's go to something more sophisticated now. Let's do data binding. So this is going to show us. And by the way, this server is a very slow server. So every time I hit one of those samples, it's actually hitting the server, but it's a free server. So pardon me if it's usually fast. Like, let me show you. When the server is active, it's very fast. But if I don't click for a while, the server sleeps. That's why that's happening. Sorry about that. But yeah, anyway, so this one is doing data binding, but not unidirectionally. This one's actually doing bidirectional data binding, which is even more sophisticated. So again, with expressive Ruby syntax, bidirectional data binding is no longer a complicated problem. Like, it's not a problem or complicated to use anymore. With Ruby syntax, it can become feasible to use in everyday development. So for example, here, I'm taking the value of an input that assumes a type of number from 0 to 100, and I'm data binding it bidirectionally to the number attribute on a number holder model. So that means every time the user inputs something here, it gets stored there. But then if I input something from this input instead, and it goes into the same variable, it's going to come back here and update the inputs bidirectionally. So let's demonstrate this example. So there you go. This is bidirectional data binding. See, when I update this, it updates this. And then if I update this here, like that, it updates the other one. That's because they're both bidirectionally linked to the same variable on the same model. So this is showing you super simple bidirectional data binding. So simple that it's practical for use every day. It's like so little code. I barely wrote any code, basically. And the model is just a number holder model that has a number value that starts at 50. Let's go into something else. This is another data binding example. This is an example where we're data binding variables on an address. So I have a street, a city, state, etc. And then at the bottom, I have, let's see. Let me run the sample just to remember what it did. Oh, there it is. At the bottom, actually, here, we have an address summary that will get recalculated every time we change one of the address fields. And using computed data binding, if any of those fields on address change, it'll take the summary and shove it into the inner text of a div using unidirectional data binding. So this one's doing unidirectional. But yeah, if we come back here, so this summary at the bottom is data bound to the data that's here. So if I type here, see, it changes it. If I delete here, it changes it. I can change the city. I can change the state. There you go. And even the checkbox is data bound. So this is demonstrating more advanced versions of data binding being in use together. Next, I'm going to go into content data binding. So content data binding basically lets me see this content here. It'll adjust dynamically based on how many addresses I have. So if I have 2 addresses, now I have 2 forms. If I have 3 addresses, now I have 3 forms, just to show you. Like, yeah, there you go, 1, 2, 3. And if I type, each one of the addresses will actually have its own summary. But the key point is that they're linked to how many addresses I have. So this content here has content data binding, meaning it's data bound to how many addresses I have. So if I were to, just a second, content data binding, to look at the code, there it is. If we have a div, we can nest within it a content block, and we data bind it to the address count on user. That way, every time we change the address count using that spinner that I showed you, this basically Ruby block, this do end block from here all the way to the bottom here, will get re-rendered. So this entire section will get re-rendered. And it's basically related, like, so this is a way of doing the MVC version of redrawing part of the page based on changes in a model. Because the key thing about it is that the redraw will only happen if the model changed. But if the model doesn't change, then no redraw is needed. So here, when it redraws, it just goes through the addresses of the user. They have 3 addresses, then it's going to re-render. It's going to render 3 forms. And typically, in a real app, I would have a component. So all of this code is not needed. I can just have one line that is rendering an address form component. But here, this is a rudimentary example, so that's why I have a lot of code. And then every address form has its own style if you need that. So let's go into something more sophisticated. So components. Let's talk more about components. So here's an app that has an address form component, and it's using it twice: a shipping address and a billing address. So this is a very common pattern. And if we were to go and check out where we declared the address form component, there it is. So when you declare a class as an address form in Ruby, and you include Glimmer Web Components, Glimmer, by convention, will automatically generate a component with the name, with the underscored version of the class name. So it becomes lowercase address underscore form. And then that's what we used at the bottom. So here, we were able to use the component version of that address class. And here it takes an address. So this is an attribute or an option. You can declare options here. So I have one option. It's just address. So this is the input to the component. The options are the input of the component. It's also aliased as attribute. You can call it attribute if you prefer. You can do things before render and after render if needed. Usually before render, you set up variables, and after render, you set up listeners. But I don't need anything for this one. And we just have a form, and it's doing data binding for every address field. So we have a full name, a street, a city, etc. And there you go. It rendered 2 addresses, a shipping address and a billing address, and they have 2 different values, different data, and they're linked to different stuff. So like if I type here, it updates it here. If I type here, it updates it there. Okay, next is component slots. Component slots lets you take an address form and add an address header and address footer if you want. So you can build components that are open for extension and closed for modification. Meaning, if I want to make an address form that supports adding user instructions at the top and user instructions at the bottom, you can basically declare those 2 slots, a header and a footer, and then consumers can basically put stuff in the header and the footer. So if I run it, those address forms now have this header here and this footer here, and this header here and this footer here. So that means even if you design the address form a certain way, you can keep it open for extension so that anybody consuming your component can add stuff to it on top of what you did. And then there's component listeners. So component listeners let you declare custom listeners. For example, if I have an accordion, I want to make sure that every time I close one of the sections, every time, sorry, I open one of the sections, it closes the others. So that means every component, every accordion section has to have two events, collapsed and expanded. And I can listen to them and see if I click here, see here it said accordion section 2 is expanded. If I click here, it says accordion section 3 is expanded. So this is by declaring custom listeners. So you can have component custom listeners. And I basically, if I go to, let me zoom in. If I go to accordion section, there it is, accordion section. There it is. You just declare events. I have an expanded event and a collapse event. And then here, I have to notify listeners in the middle of the implementation. So on collapse, and notify listeners that I collapsed, and on expansion, it notifies them that we expanded. And then I have something that listens to those listeners here. See, on expanded, do this. On collapse, do this. So this way, you can have your components support any kind of arbitrary custom events if needed, which is very realistic. That's how real life works. Like if I have a car component and it moves, and you want a car moved event, you can declare it. So that's about it for that. Hello form is just refactored the form that I showed you earlier into components. So now I have a contact form and a contact table. And if I run it, it's the same form that I showed you earlier. Like I can type stuff here and it adds it, but I have a contact form and a contact table as very simple components, which is the way we write real business apps. Real business apps, I want the code to be very compact like this. And then if I want to dig into the details of the contact form, I can dig into it separately. And I do have it here in my editor. If I open contact form, there it is. Here are the details of that form specifically. And here's the input that it receives. It expects a presenter. Presenter is the type of a model that's responsible for view logic, but that's about it. And yeah, I think we did it. We went through all the important samples. So let me get back to the slides and talk about that. What did you guys see? So that Glimmer Ruby HTML DSL basics is that the HTML DSL enables building web user interfaces with Ruby using an embedded DSL. The first key concept you want to learn is element keywords. And basically, it's the names of the elements. And it could be HTML, could be head, could be body, form, input, etc. Anything you could do in HTML, it could do in Glimmer, because Glimmer does produce real HTML in the end, including custom components. You can build your own custom components. So yeah, you can go find the full list of HTML elements here. I'm sure you guys know most of them, or if not all of them. The next thing you need to learn is arguments. So arguments enable you to pass HTML attributes or text content. So this is optional, but basically, if I have an element that takes that usually will be used as a text holder, like a header, for example, you can pass the header as the first argument, the text of it, and then now we have a header that says contact form. But if you want to pass extra arguments, like attributes, you can then pass them as keyword arguments. So I have an ID in a class, and the content of it is this text. An input field doesn't need text, so it doesn't need the first part, but it has the attributes. And yeah, any attributes supported in HTML is supported here. The third concept you need to know is content blocks. Thanks to Ruby blocks, the feature of Ruby blocks enable us to do declarative content blocks with the Ruby HTML DSL. So you can put in those properties or event listeners or nested elements or string content if it's the last value in the block, if it's the return value. So for example, I have a div. I can declare a property of inner text and put a value in it. And then I have an input. I can set a value to user.email, or I can put other stuff there. I can nest other elements if I want. But anyways, any properties supported in HTML are supported here too. And then the next part is listeners, event listeners. So any listeners that are supported in HTML are also supported here with the same exact keyword. So if you have onClick in HTML, usually the value of onClick is JavaScript code. Here, since we're in the same language, I don't have to put a textual value anymore. I can put real Ruby code in it. So instead of setting it to a string, I set it to a do-end block, because in Ruby, you can always pass a block to a method. And here, you can do the work that onClick would do that it would have done in JavaScript. So it always starts with the on prefix. It's an observer pattern, and it supports everything that's in HTML. You could do more sophisticated stuff like I showed you earlier, and everything is supported here as well, like on change, on click, on copy, on double click, on key down, etc. Everything in HTML is supported here. Next is nested elements. So that's like nesting a TD, table data, within its table row, within a table. So that's like the composite pattern, because every element is composed of other elements. Here we have a form that has a div that has a label and input. That's another example. And if you have just a header and you want to put text in it, you can put it as a string in Ruby. So this would be a string. So you would single quote it or double quote it and put it as the last value of the block, and it becomes the return value. So that's one of the niceties of the Ruby DSL. It's very close to HTML. It doesn't get closer than that, except it's more dry than HTML. In HTML, you have to have an opening H1 and a closing H1, whereas here it's dry. I don't have to repeat myself. I can just type the H1 once and I'm good. And this is a paragraph. This is a paragraph that embeds other stuff, like it has the strong tag, the embedded tag, sorry. This is a way of embedding tags within tags in a string using a Ruby string interpolation. So again, Ruby gives us a lot of niceties because of its DSL support that Glimmer takes advantage of. The last thing is element methods. So any DOM methods that are supported on elements in HTML, they're also supported in Glimmer using Opal Ruby. So it matches the HTML DOM API. So for example, here we're using the check validity method, or we're checking the value method, or focus. They're all supported here too. So again, we're writing everything in one language without switching between too many different languages, which helps with productivity. Okay, let's go on. So ideally we would follow the MVC pattern. So we have a view that is monitoring the model for changes and then updating itself. And then we have a controller that's monitoring the view for any user interactions, like mouse up, key up, selection, or clicking a button, or changing a select box, etc. And as soon as it receives those events, it manipulates the model. And the correct way of doing MVC, according to Smalltalk MVC, is you would want the controller to only manipulate models, but never talk to the view directly. It would only listen to view events. And then the model, when it changes, the view is listening to the model, and it'll update itself. So all of that is supported in Glimmer. You could use the observe keyword to do the observer pattern explicitly, or you could use data binding to do it implicitly. I already showed you the observer example, and I did it with data binding, but it could also be done using the observe keyword. Let me see. Yeah, here we're using an observe keyword. We're having the view observe this attribute on a model, and then it updates itself. So that's the way of doing it, the classic MVC way. The more modern MVP way, so model view presenter is the more advanced version of MVC. It has a presenter here that will listen to view changes and update the model. It'll listen to model changes and update the view. That's like bidirectional data binding, basically. This is a lot simpler. I can just write a lot less code this way. I don't have to use the observe keyword directly. I can just use this double arrow and say I want to bind this to that, and we're done. From that point on, whenever I make changes to either side, they're going to update the other side. So that enables a lot more productive programming of front-end web interfaces. And here I'm using unidirectional data binding. So some attributes are unidirectionally data bound because the view will not let you influence the attribute, kind of like the text of a div. The div is not a button. It doesn't or it's not a text field, sorry. Doesn't let you edit it. It's usually uneditable. But it has a text. So here, what I'm more interested in is every time I update the text on an address, I want it to update the inner text of a div. And then I can add options. And here I'm saying on read of the data from the model. I want to convert the value. So I'm using a converter. This is an on-read converter. I want to convert the value into a string that has the value embedded within this statement. And it'll copy it here, and we're done. So, and there are more advanced versions of data binding, like inline style data binding. So every element has inline styles, like width, height, like basically CSS properties, like width, height, font size, background color, border color, etc. The dashes, by the way, in CSS become underscores in Ruby, and these become symbols. But yeah, I can use unidirectional data binding and have basically model attributes. So if I have a button model and the width attribute on it changed, I can have it update the width inline style of an element automatically. So this is very, very helpful here. And honestly, this was partly inspired by Vue.js. Vue.js supports that as well. But I think Ruby does it even better than Vue.js, because here we're inside Ruby code, whereas in Vue.js, you're not inside Ruby code. You're in like HTML, which is not as fluid as Ruby. Here's another version of that. That's CSS class inclusion data binding. So here we're saying if this attribute is set to true, it's a Boolean. It's expected to be a Boolean. Then I want to add the pushed CSS class to my element. If it's not set to true, then I want the pulled CSS class to be added to the element. So this is a way of switching CSS classes with very little code based on attributes on models. So again, it enables us to decouple the view logic from the view and put it in models that are presentation models. And this makes the views a lot more readable, and they end up with a lot less code, so they're more maintainable as well. So this is the data binding version of Hello Observer, which I already demonstrated. Content data binding, I already talked about. It's just, you say content model attributes, and every time this changes, this entire block is going to re-render. And that's about it. So next, let's talk about components. So components are Ruby classes that mix this mix-in or module, Glimmer Web Component. And then it generates a word matching the class in underscored form. So address form becomes address underscore form. You can pass options or attributes. And then the body of it is in the markup block. And it's got a before render block and an after render block for extra work if needed. And then we can render it, or we can embed it within ERB using the Glimmer component helper. I'm not going to get into those details. I'm just giving you a quick overview. And then we have the slots feature, which I talked about, which is the ability to add slots to components. So that way consumers can contribute extra stuff, like an address header, for example, which will show up here. And then custom listeners, I already talked about it, like declaring listeners for expansion and collapse of an accordion section. That way I can listen to them and do some stuff according to that change. The Glimmer component Rails helper enables us to embed any Glimmer front-end component inside a Rails ERB template, because Rails uses ERB for the view files. So I can use the Glimmer component helper to embed Glimmer front-end HTML within ERB files. So this is very similar to React component for people that have used React with Rails. In React, we say React component. In Glimmer, we say Glimmer component. It's the same exact thing. You can pass it options. So here's an example of it. Like I embedded an address form, and I passed it options, which is all the arguments that it would expect. And it's the same way React does it, but we're doing it with Glimmer here. And it's embedded in an ERB file in Rails. Formatting elements is just a type of elements that have special treatment to enable us to embed them within a paragraph in this using Ruby string interpolation. I'm not going to get into it, but Glimmer provides support for it. So there's a Glimmer DSL for CSS. I didn't get into it much, but basically you just say inside any style block, you can say I want a rule for .main or for .toggle all or for any CSS expression you want to put here. And then you just open a Ruby block and then you declare CSS properties. In Ruby, I can use Ruby syntax where if it's a pixel number, it's assumed that pixel is the default. So with convention over configuration, 1 will always be assumed 1px. So that saves me from typing px when most of the time we use px. But also you can do .% if you want a percentage, or .pt if you want to use pt instead, or you can just pass a string. But typically you can pass symbols, Ruby symbols, which is less typing than a string because you only have this in front of it. You don't need a closing single quote. There are times when you do need a string, but anyways, this enables us to, this is very similar to styled components. So any component in Glimmer is just like styled components in React, and it enables you to keep the styling close to the component so that you can maintain it in the same file and be more productive. And then HTTP or Ajax requests is a very important part of front-end development. So there's an HTTP class that comes with Glimmer that lets you do anything with an HTTP. Like you could do a get, a post, a put, delete, etc. You can pass it options, and then you get a response, and then you can do something once you receive the response. You can also integrate with other JavaScript libraries. By the way, I was using this for the sample selector that I just showed you. Every time I clicked on a sample, it was making this call to the back end and receiving the sample's code, and then embedding, setting it on the selected sample code attribute, and it's data bound unidirectionally to, let me go back here. Data bind unidirectionally to this part. That's why this part was updating every time I clicked on a sample here. But one thing I was trying to say is you can integrate with any existing JavaScript libraries, including Axios. If you prefer to use Axios for HTTP calls, you could do that. So you could either include in your HTML a script tag to whatever JavaScript you want to integrate with, or you can require it directly in Ruby using Opal Ruby. So Opal Ruby allows you to use the Ruby require keyword, not only to require Ruby code or import Ruby code, but also to import JavaScript code. So for example, we use that in the Rails sample selector app to integrate with Highlight.js, where we do Ruby code syntax highlighting. I already demonstrated it. I didn't code the syntax highlighting myself that you guys saw. Like this nice syntax highlighting is not, I didn't do all the work myself. I integrated with a JavaScript library called Highlight.js, and it did all the work for me. So you could definitely integrate with any existing JS work in Glimmer. This is kind of similar to like the previous talk on Elixir and its integration with Erlang libraries. Here, we use Opal Ruby, and you can integrate with any available JavaScript library. So you have access to the entire JavaScript ecosystem from Ruby, which is great. Finally, I can dig a little bit into the to-do MVC code. We have a bit of extra time, so let me dig a little bit into that. So the main to-do MVC component, I already showed it. It's got a new to-do form, a to-do list, and to-do filters. So if you look at the top here, I'm saying require relative new to-do form, which is relative to where I am. So if I click on regular, and see, we have this directory now. It has got models, presenters, and views, because it's following the MVP pattern, which is a variation on MVC. And then there's the new to-do form. And it's just a header, and it's got a new to-do input component. So I can go here, new to-do input, and there it is. The new to-do input is basically an input that is bidirectionally bound to the task value on a to-do object on the presenter. And if I type on key up, meaning on every key that I type on the keyboard, it's going to check if I hit enter. If I didn't hit enter, it'll do nothing. But here, the value would get persisted into this model. But if I hit enter, it's going to create a new to-do. So basically, this is what happens when we, let's go back to to-do MVC. Yeah, if I type, nothing happens. But if I hit enter, it just created a new to-do object. So that's what that code is doing. And as you saw, like it's very little code. It's only like almost 2 lines of code, and it's doing everything. It's pretty amazing. And if we go back out and we go to the to-do list, the to-do list basically has, there it is. It's got a UL, and which is an untitled list. And then here, for every to-do in the presenter, every to-do model, we render a to-do list item component. So let's look at to-do list item. So this to-do list item component is rendering LIs, basically. And it's doing some data binding on those LIs. So you could do whatever you want here, or you could extract any part of this code and have other components handle it. So you have the flexibility of both options. But yeah, you can see it's very little code. That's the amazing part of this. Compared to what I write with HTML and JavaScript, this is like very, very little code. So why Ruby in the browser? To improve developer productivity with an isomorphic application architecture. Significantly better front-end code readability and maintainability via Ruby's awesome unique syntax features like blocks and operator overloading. Ruby metaprogramming facilities are amazing. Ruby's ability to build declarative internal DSLs enable us to do a one-language approach instead of having to mix JavaScript and incompatible languages that don't fit well with JavaScript. For example, like non-dry HTML, which forces you to repeat every tag twice if you have a container tag. Yeah, this is an example of a Ruby DSL generating real HTML. So you write a lot less code. You can obviously see how less code you write on the left side, which enables you to focus on the business features that you're developing and not worry about low-level details. Ruby has excellent core and standard libraries, like everything in it for array, hash, enumerable, string, symbol, etc. is pretty cool. JavaScript libraries can be used from Ruby with enhanced Ruby abilities for better readability, maintainability, and flexibility. Here we're using jQuery, but in Ruby you say element instead of $. And then I can use Ruby features like reject and select, which enhances the syntax significantly for jQuery. Reuse some Ruby gems on the front end. So I've successfully used many Ruby gems that were available on the back end and implemented in pure Ruby on the front end with no problem, including the Glimmer engine. The Glimmer engine was originally built for desktop development, but I was able to repurpose it for front-end development. Save development time by sharing reusing Ruby code between front-end and back-end, which is only doable in Ruby. It's not doable in JavaScript. Transfer developer Ruby skills from back-end to front-end. So I'm not going to talk about the future, but there's a lot of exciting stuff happening in the future. You guys have the slides, so you'll be able to go through it. I need to wrap it up to let the next speaker set up. But yeah, so you can basically take a screenshot of this if you want a copy of the slides. And then you can check out the next Montreal RB meetup in December. It's going to be a hands-on hack event, basically, hack night. So, and you can scan this code to get that meetup. I'll put this code for the slide. So yeah, thank you very much.